Hi everyone, I am Jennifer Hicks, and today I will be discussing my final project for USF's Make Course Elective, Disney's Cogsworth the Clock. I will begin with a brief intro on my project and its control system. After that, I will go into further detail about the functionality and show a demonstration of the project. Let's begin. Cogsworth is a clock, therefore his movement relates to time. In this simulation, he will wiggle back and forth 3 times to represent 3 o'clock. Once he has completed this, his shoulders, arms, and hip bend to finish with a bow. To complete this function, Cogsworth requires 5 servo motors, all controlled by an Arduino board. This shows the overall block diagram of the control system. As I said before, time begins each simulation. The Arduino then controls 5 servo motors. Servo 1 controls the waist, servos 2 and 3 control the elbow, and servos 4 and 5 rotate each shoulder. Here's a closer look at the fritzing diagram of the system. As you can see, each servo is connected to a 5-volt power source, ground, and its individual input pin. Now let's go into the design of how each servo produces its motion. For the movement of Cogsworth's base, I used a simple gear mechanism. The base servo rotates back and forth in order to move the rest of the body. Here is the demo of some of the initial testing on the base servo. This image shows the final gear attachment to the belly. Along with this, you can see the groove that was produced specifically to limit the amount of weight on the servo. In the arms, I intended to use a crank slider mechanism to control each hand. Additionally, a servo motor would be mounted to the outside of the shoulder in order to rotate it back and forth. Ultimately, an aluminum wire was used to push and pull each hand due to the small size of his hands. To complete this, each large servo was screwed securely onto each shoulder and mounted onto the inside of his belly. This is a video of the initial testing for the arms. Overall, this project required a total of 27 parts to complete this goal, and ultimately he did. Here is the final simulation for my Cogsworth Animatronic. Thank you, USF Make Course, for giving me such a unique experience that allowed me to learn about design, electrical systems, and C++.